Hello, year 8s, and welcome back to mathematics. In today's lesson, we're continuing with our topic of measurement, and we're actually going to have a look at one of the final sections in this section on measurement. We're having a look at something called Pythagoras' Theorem. And so in these next couple of lessons, we're going to be actually looking at questions where we are working with a bunch of special triangles called right angle triangles, and I'm trying to figure out what the relationships are between the sides of a triangle. So here, in today's lesson, we want to be able to understand what Pythagoras' theorem is. We want to firstly identify the sides of a right angle triangle. Secondly, identify the formula for Pythagoras' theorem and check for Pythagorean triads. So that's the three things we're going to be looking at today. So let's get into it. What is Pythagoras' theorem? Now, Pythagoras' theorem is a theorem that has been named after a fairly famous mathematician and philosopher named Pythagoras. So Pythagoras lived in roughly 570 to 495 BC, and he was a famous Greek mathematician and philosopher. And he actually thought about a whole bunch of different things and had a whole set of ideologies in terms of the way that you should be living. One of the reasons why he's most famous is because he came up with a relationship that actually related the three sides of a right angle triangle. Now, a right angle triangle is just a triangle that has a right angle in it. So if you have a look at my triangle here, there's a right angle in the bottom left. And so that's what it means for a triangle to be a right angle triangle. Now, in particular with the right angle triangle, Pythagoras actually noticed a pattern with the three sides of a right angle triangle. So with this pattern, we actually need to know one particular side of our right angle triangle, which is called the hypotenuse. Now the hypotenuse is this side over here. So I'm just going to label it. This side over here. This side is called the hypotenuse. Hypotenuse. The hypotenuse is just part of the right angle triangle, and it has there's a few ways that you can tell which side is your hypotenuse. Firstly, it is the longest side of our right angle triangle. So longest side of our right angle triangle, of the right angle triangle. And the other thing is it's directly opposite this right angle. So if you have a look, no matter what right angle triangle you have, the hypotenuse is always going to be the side which is directly opposite the right angle in your triangle. So opposite the right angle. And so here, this is a particular side that we need to be able to identify from a right angle triangle. So the right angle triangle, there's always going to be a hypotenuse, and hypotenuse is always going to be opposite the right angle, and it's also going to be the longest side of your right angle triangle. Now, Pythagoras actually noticed there was this pattern between the three sides. So what I'm going to do is I'm actually going to name the three sides. The two shorter sides, I'm going to call this side A, and this second side B. So it doesn't matter which order I do it in. The one on the left could be A, the one on the bottom could be A. Doesn't really matter. But for the final side, the hypotenuse, I'm going to name this C. And it's going to be really important that the hypotenuse is always C for this particular relationship. And the pattern that Pythagoras noticed, and this is called Pythagoras' theorem, is that if I square all three of my sides, so if I take A and I square it, so I times it by itself, and then I add on top of that B squared, so I square B and add it with A, that is always going to equal to the square of the longest side. So here, Pythagoras' theorem is A squared plus B squared is equal to C squared. And so the square of the two shorter sides of my right angle triangle is going to equal to the square of the longest side of the triangle. Now, I said that Pythagoras noticed this, but actually this particular rule wasn't first discovered by Pythagoras. It was actually discovered by a whole bunch of other people and a whole bunch of different cultures. They actually all came to this realization about this particular pattern about a right angle triangle. So for example, in ancient Babylonians and Egyptians actually came up with this relationship as well, and Egyptians noticed this pattern all the way back in, what time was that? 1900 BC. So like a full 1,400 years before Pythagoras. And not only that, Indians also discovered it, and along with that, so did Chinese people, like all a long time ago too, and also ancient Chinese people. They also discovered this relationship as well. So it's not just Pythagoras. The reason why it's called Pythagoras Theorem is that some people discovered the Greeks' understanding of this particular theorem, and then they were like, oh, cool, we're just going to name it after Pythagoras. But just if in the case you're interested, it wasn't just Pythagoras who discovered it. There was a whole bunch of other cultures that discovered it as well. But bringing it back to the maths, here Pythagoras' theorem just tells me that no matter what right angled triangle I have, if I take my two shorter sides and I square their lengths, so a squared and b squared, and I add them together, it's going to equal to the square of the longest side. And so what we're going to be doing today is actually working with a few numbers to see if they actually fit into this pattern. So the first thing we're going to talk about is a thing called a Pythagorean triad. Now here, a quick definition. A Pythagorean triad is a group of three whole numbers which satisfy Pythagoras' theorem. So it's a group of three whole numbers which satisfies Pythagoras' theorem. So if I can find three numbers that when I square two of them and add them together, it gives me the square of the last number, that will be, that satisfies this condition of Pythagoras' theorem, and so is called a Pythagorean triad. So the way that we can check whether or not numbers are Pythagorean triads is what we're going to do. We're going to square all three numbers. So the first step is we're going to square all of the three numbers. Then what we're going to do is then we're going to add the squares of the smaller two numbers. So we take the two smaller ones and we add them together. Then the final thing that we're going to do is just check if it's equal to the square of the largest number. And if it does, that means we have a Pythagorean triad. So let's have a go with a couple of examples of this. So determine if the following sets of three numbers are Pythagorean triads. So let's have a go at the first example. We've got 6, 8, and 10. So if we want to check if these are Pythagorean triads, what we're going to do is we're going to square all of these numbers. Now when you square a number, that just means you're multiplying it by itself. So 6 squared is just 6 times 6. 8 squared is just 8 times 8. 10 squared is just 10 times 10. And luckily for us, there's actually a shortcut on our calculator. So if you have a calculator, this actually makes it a lot easier. There's a shortcut on our calculator to actually do this. If I go 6, and then there's this little button that says x squared, if you have a look. If I press that, it'll just square my number. So here, 6 squared is going to be 36. 8 squared, and if you know your times table as well, this is actually quite easy to do because you can just, if you remember your times table, it's quite easy to just rattle off the numbers here. 8 squared is going to be 64. There we go, 64, and then 10 squared, I believe, is 100. So here, this is going to be 100. Let me just check that. 10 squared is 100. Excellent. Okay, so we did that first step. We have squared all of our three numbers. So we did 6 squared, we did 8 squared, and we did 10 squared. So we've squared all of our numbers. Now what we're going to do is we're going to take the two smaller ones. So we're going to take 8 squared and 8 squared and 6 squared, and then add them together. Pythagoras' theorem tells me that if I add the squares of the two shorter sides of my right angled triangle, it should give me the square of my longer side. And so when I add these two numbers, if it equals to the square of my longer side, so here in this case 10, that means that these three numbers fulfill Pythagoras' theorem, and they become a Pythagorean triad. So let's have a look at this. So I'm going to do 6 squared plus 8 squared, and that's equal to. So let's put this in. And I'm actually going to move a few things out of the way so I can get enough space to do this. There we go. Okay, 6 squared plus 8 squared is just going to be, well, we found 36 plus 64. And if I do 36 plus 64, 36 plus 64, that's going to give me 100. And if you have a look, well, 100 is what I actually found out 10 squared to be. So this is equal to 10 squared. So we've got 6 squared plus 8 squared is equal to 10 squared. And so this works out perfectly. This is an example of a Pythagorean triad. So therefore, we've got a Pythagorean triad. Okay, let's have a look at the next example. We've got 4, 5, and 9. So once again, what we're going to do is we're going to square each one of our numbers. So we're going to do 4 squared, 5 squared, and 9 squared. So let's do this. So 4 squared, I believe gives you 16. 16. 5 squared will give me 25. And 9 squared, I believe, will give you 81. Okay, there we go. 4 squared, 5 squared, 9 squared. So if you want to do this in your head, you're just thinking 4 times 4. 4 times 4 is 16. 5 times 5 is 25. 9 times 9 is 81. So when you square, you're not timesing it by 2, but you're actually timesing it by itself. So here, once we've done that, we're going to take the two smaller ones, 4 and 5, and add them together. And if it equals to 9 squared, so if it equals to 81, that means that these three numbers are Pythagorean triad. So let's do that. So here on the right hand side, I'm going to go 4 squared plus 5 squared is equal to, well, we've got 16 plus 25. 16 plus 25, I believe, gives me 41. So let's just chuck that in a calculator. Check. 16 plus 25 is equal to 41. And if you have a look, that's not equal to 9 squared. And so this tells me that this is not a Pythagorean triad. So not a Pythagorean triad. Because it doesn't fulfill that Pythagoras' theorem, it is not an example of a Pythagorean triad. And so this is not a Pythagorean triad. So Pythagorean triads are sets of three numbers, three whole numbers that fulfill or meet the criteria of Pythagoras' theorem. A squared plus b squared is equal to c squared. And if we square the two smaller numbers and add them together and it doesn't equal to the square of the larger side, that means that we don't have a Pythagorean triad. Okay, so this particular skill is quite helpful for us because using this, we can check whether or not a triangle is a right-angled triangle. In order for a triangle to be a right-angled triangle, they need to fulfill Pythagoras' theorem. We need to have the square of the two shorter sides being equal to the square of the longest side, the hypotenuse. So we can actually use this to help us check if if a particular triangle is a right-angled triangle. So that's what we're going to do in the following example. Determine if this following triangle has a right angle. So if I look here, we've got my three sides, 4, 7, and 9. And so what we want to do is see whether or not this fulfills Pythagoras' theorem. Does it fulfill that? Do these three numbers make a Pythagorean triad? And so what I'm going to do is I'm going to actually do the same thing we did up above. We're going to square all of our three numbers. So I've got 4 squared, I've got 7 squared, and I've got 9 squared. So I'm going to take all of these three numbers and square them and then check using Pythagoras' theorem. So I'm going to add the smallest two numbers after that. So here, 4 squared is going to give me 16. 7 squared is going to give me 49. And 9 squared is going to give me 81. We actually did this one earlier as well. So now that I've done that, I'm going to add the smaller two sides. So Pythagoras' theorem tells me a squared plus b squared is equal to c squared. So a is just a and b are my two shorter sides, so a and b. And c, it has to be my longest side, so this 9 here. And if these two, the sum of the two smaller sides adds the sum of the squares, so when I add up the squared versions of my two shorter sides, if it equals to the square of the longer side, that means I've got a right angle triangle, and that's great. Okay, so let's do this. So 4 squared plus 7 squared, that's equal to 16 plus 49. 16 plus 49 actually gives me 65. And so if you have a look here, 65 isn't equal to 81. So therefore, this is not a right angle triangle. Not a right angle triangle. So here in this particular case, because it does not satisfy Pythagoras' theorem, this means that there's no right angle inside my triangle. All right angled triangles, no matter what size or what shape it looks like, it will always satisfy Pythagoras' theorem. A squared plus b squared is equal to c squared. And if it doesn't, that means it's not a right angled triangle. So that's it. So that's it for today's year 8. Let's just do a quick recap of what we looked at in today's lesson. Today we talked about Pythagoras' theorem. Pythagoras' theorem gives me a relationship between the three sides of my right angled triangle. A squared plus b squared is equal to c squared. And so a and b are my two shorter sides and c is my hypotenuse, the longest side of my right angled triangle. And so if I square the two shorter sides and add them together, for any right angled triangle, it should always equal to the square of the longest side. And so what we were able to do is we could check if three numbers made Pythagorean triads. Pythagorean triads are just three numbers that fulfill the criteria of Pythagoras' theorem. And we also then went on and used this skill to actually help us check if a particular triangle had a right angle in it. So that's it for today's lesson year 8. If there's any questions, feel free to send me an email or a message on Google Classroom. I'm more than happy to try and answer your questions. But until then, I hope you guys are staying safe wherever you are, and I'll see you in the next video. Bye.